In this video, we are going to be talking about bond polarity, so you will be able to determine if a bond is polar covalent, nonpolar covalent, or ionic using electronegativity values by the end of this video. While you're watching this video, this is the only thing you should have open, and you should be using headphones to listen to what I'm saying. Please don't just read the text and assume that you understand. Please listen to my explanation. These videos should not be more than 10-15 minutes to complete. Make sure you're taking notes, so write down anything I read or anything that I'm writing down into your notebook. Answer the questions that are within the video, and then I will be checking both the questions and your notes for accuracy. Before we get into bond polarity, we are just going to review electronegativity. So electronegativity, as we remember, is an atom's ability to attract an electron. The closer it is to having 8 valence electrons, which is over here on the periodic table, the more it attracts electrons, the higher the electronegativity number or value. The less it is, or the further it is from reaching 8, so those that have 1, 2, 3 valence electrons, their electronegativity value is going to be lower because they want to lose electrons. They don't want to gain. We have 2 types of bonds. We've already looked at ionic and covalent. Ionic is when one element loses electrons and one element gains. They're on opposite sides of our periodic table, and this happens through a transfer from the one that's losing to the one that's gaining. It gives its electrons away to the one that's gaining electrons. And that's because our one that loses would have a low electronegativity. It doesn't really want to attract electrons, and it's giving its electrons to the one that has a high electronegativity. Because it really wants to gain. And then covalent bonds, we know, are 2 elements that share electrons because they both want to gain electrons to meet the octet rule, so they compromise and share them instead of transferring. Specifically in this video, we're going to be looking at what we have are polar covalent bonds and nonpolar covalent bonds. So there are different ways that electrons are shared, and that's what we're going to be looking at today. So polar covalent bonds are when electrons are shared unevenly, and that's because the difference in electronegativity is pretty big. Not as big as ionic, but bigger than if they were nonpolar covalent. So I know that they don't have equal hold on the electrons. One has it closer to the other one, but how do I know which one it will be closer to? That is going to be the one that is more electronegative. The one that's more electronegative wants to meet the octet rule more, and so it has a stronger attraction to it. So in this case, if you look at our picture, chlorine has the electrons closer to it than hydrogen. That means that chlorine is more electronegative. And hydrogen would be less electronegative. If I were to draw this as like an actual bond, our bond would be pretty similar. I have chlorine, I have hydrogen. I'm not drawing all the valence electrons. I'm just going to draw the bond to show you where the electrons would be. If I know Cl is higher and H is lower, I don't want to put them in the middle because that would mean equal sharing. I want to put them closer to where it's higher, so that would be chlorine. So I'm going to put my 2 electrons, and it's 2 because they each share 1 from chlorine, 1 from hydrogen. I'm going to put it closer to chlorine because it's higher. It has more attraction to the electrons than hydrogen. Nonpolar covalent bonds are when they share electrons evenly, and that's because each element has an equal pull on the electrons, which means their electronegativity is similar. They attract electrons pretty much equally. And so if we are looking at this picture, we have two hydrogens. Because they're the same element, we know they're going to attract electrons the same amount. And so if I were to draw that, because they share equally, I'm just going to put those two electrons in the center because it's equal. Now, important thing to remember here is that not all nonpolar covalent bonds are the same element. They're not always going to be hydrogen and hydrogen, chlorine and chlorine. You can have two different elements, like I think carbon and sulfur. Yes, carbon and sulfur would be an example of nonpolar covalent with not the same elements. So for a comparison for you, nonpolar covalent bonds would be like divorced parents, where the kids spend equal time with their parents. But polar covalent would also be divorced parents, but you spend most of the time with one parent. And you occasionally see the other parent. And like we discussed in class before, ionic transfer is like where you only ever live with one parent. The other parent just like transfers the custody to the one. That's just like the electrons. And so it's a weird comparison to talk about bonds and divorced parents, but it's an easy way for you to remember how they share and like what they do with their electrons. So how do we figure out if it's nonpolar, polar, or ionic? To do that, we need to use the electronegativity values and calculate the difference. The difference, or your answer from this equation, is going to fall into one of three categories. Nonpolar, where it's less than 0.4, polar, 0.4 to 1.7, or ionic, 1.71 and above. So nonpolar covalent, the number is pretty small because they have equal share. Polar covalent, the answer would be a little bit bigger than nonpolar covalent because they still share, but one has more attraction. And ionic is a really high number, a really big difference because you're just transferring electrons. And the equation you're going to follow is element with higher number minus element with the lower number. It's just easier to remember than like the absolute value, which would be the same equation. So we're going to do oxygen and sulfur first. So looking at my chart, oxygen has a value of 3.5 and sulfur has a value of 2.5. So I'm going to do bigger number minus smaller number, 3.5 minus 2.5, which gives me 1.0. Now 1.0, if I'm looking at my chart, is not less than 0.4. So I know it's not nonpolar covalent, and it's not bigger than 1.71. So I know it's not ionic. It's in between 0.4 and 1.71, which means that this is a polar covalent bond. So they share electrons, they just share them unequally. So when we draw that, I'm going to draw O, I'm going to draw a line, I'm going to draw my S, and I'm going to write my values underneath 3.5, 2.5. So I know they're sharing unequally. I'm going to put my electrons closer to the one that has the higher number because it's going to attract electrons more. So I'm going to put my two electrons, one from oxygen, one from sulfur, closer to oxygen to show that one, it's unequal, and two, oxygen has a higher electronegativity value. Okay. So the next example we are going to do is phosphorus and sulfur. So we know from the last number that sulfur is 2.5, and phosphorus, if I look at my chart, phosphorus is 2.1. So I'm going to do bigger number minus smaller number, 2.5 minus 2.1. That is going to be 0.4. And so I'm going to take that number and I'm going to go back to my chart. So 0.4 is definitely not bigger than 1.71. And it's not less than 0.4. It's exactly 0.4, which means it is polar covalent. So drawing that again, PS, my electrons are going to be closer to the number that's bigger. So in this case, sulfur has a higher value at 2.5 compared to phosphorus that has a value of 2.1. So I'm going to draw my electrons closer to sulfur. And instead of doing hydrogen and chlorine, I'm actually going to have you do carbon and sulfur. So what I want you to do is pause here and try this one on your own. And it's important that you are trying it before you check your answer or just copying it down, because it's going to help you remember and learn. But I want you to do the same thing. You are finding the numbers, doing bigger number minus smaller number, and then figuring out if it's polar covalent, nonpolar covalent, or ionic. Okay, so carbon in our chart has a value of 2.5. Sulfur has a value of 2.5. So I'm just going to write those down. These numbers are the same, so it doesn't matter which one you put first. 2.5 minus 2.5 is going to equal 0. I know on my chart that it is definitely not above 1.71, and it's not 0.4 to 1.7. 0 is less than 0.4, which makes this a non-polar covalent bond. So if we were to draw that, C and S, my electrons are going to go exactly in the middle because they share equally. They both have an equal hold on it. So I'm going to put them in the center. Whereas the other two, they were polar covalent, they shared unequal. So we're going to put our electrons closer to the higher electronegativity value. Okay. So what I want you to do now is you're going to answer these 3 check for understanding questions in the Google form. In your notebook. You're going to answer them in your notebook. Then you are going to check them with me. Once I check them and check your notes, I'm going to give you the practice questions. You're going to complete the practice questions in your notebook. Make sure you title the top of the page, Bond Polarity Video Practice 11/12/2025, so you know what you are doing on that page in your notebook. Make sure you number each question. For the practice, there's only 3, so 1, 2, 3. Show your work, all of it. Circle your answer, and then you're going to check it with me. If you don't show your work, I will just send it back to you to show it to me. And that is it.